Distinguished colleagues, dear guests, we are beginning the panel session for the defense of Liliya Yafarova. The thesis is submitted for the academic degree of the candidate of sciences in chemistry. The specialization is 020004, physical chemistry. The topic of the thesis is synthesis, physico-chemical and catalytic properties of perovskite-like, ferrites, cobaltites and manganites, and gadolinium in reactions of petrochemical synthesis and ecology. Dear colleagues, as we are waiting for one of the members of the board, I need to declare the first technical break. Thank you. Distinguished colleagues, the technical break number 1 is over. And distinguished colleagues, those who are working remotely, I believe you heard my announcement that our first technical break is over. So, let me repeat the first words that we're beginning the panel session for the defense of the thesis by Liliya Yafarova. The thesis is submitted for the academic degree of the candidate of sciences in chemistry. Specialization is 020004, physical chemistry. The topic of the thesis is synthesis, physico-chemical, and catalytic properties of perovskite-like ferrites, cobaltites, and manganites of gadolinium in reactions of petrochemical synthesis and ecology. Under the order issued by the Academic Secretary of St. Petersburg State University as of April 6, 2021, number 2762/1, I, Igor Murin, Doctor of Sciences in Chemistry, Professor of St. Petersburg State University, Solid State Chemistry Department, was appointed the chairperson of this dissertation board. The order also approved the candidacies of the members of our board, and let me introduce them. Alexander Toyko, Doctor of Sciences in Chemistry, Professor of the Chemical Thermodynamics and Kinetics Department of St. Petersburg State University. Nikolai Charikov, Doctor of Sciences in Chemistry, Professor of the St. Petersburg State Institute of Technology. The following members of the board are working remotely. Raisa Kuzmina, you can see her on the screen. Yes, good morning, dear colleagues. Doctor of Sciences in Chemistry, Professor, Head of the Department of Petrochemistry and Technogenic Safety of the Chernyshevsky Saratov State National Research University. So you hear us and see us, don't you? Yes, I see you and hear you quite well. Okay, Andrei Blakhin, Doctor of Sciences in Chemistry, Professor, Head of the Department of Physical Chemistry of Belarus State University, Belarus. Do you hear us and see us? Yes, distinguished colleagues, once again, hello. I see you well. Okay, then we continue. Taking into account the fact that our candidate for the degree, Liliya Yafarova, is present remotely using a multimedia connection, I raised the question on the possibility to continue our session like this, in this mode. So, Alexander, what's your opinion? Yes? Nikolai, yes? Raisa, what about you? Yes? Andrei? Yes, I agree with that as well. So no sound. Okay. Taking account the opinion of the members of the dissertation board, I would like to announce that we decided to continue our board session with our candidate for the degree that will work remotely. And we also have the Thesis Supervisor, Irina Zvereva, Doctor of Sciences in Chemistry, Professor of the Chemical Thermodynamics and Kinetics Department of St. Petersburg State University. So, dear colleagues who are working in the remote mode, in order to improve the quality of our connection, kindly turn off your microphones, but don't forget to turn them on when I give you the floor. I would also like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University website, and it is also interpreted from Russian into English and vice versa. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions or opinions to Ms. Yafarova online. The questions regarding the thesis or the current scientific discussion or speech. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. The questions must be related to the presentation and the content of the thesis, and don't forget to give your name and position if you submit a question. Questions that have nothing to do with the scientific discussion or dissertation to the text of the dissertation will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University approved by local normative acts, The session of the Dissertation Board is valid, providing 2/3 of the appointed board members are present. The total number is not to be fewer than 4 people. Our Dissertation Board consists of 5 people. Everyone is with us today, including 2 members of the board who are working remotely. We have a multimedia connection with all the members of the board as well as with our candidate for the degree, therefore we have a quorum. So, our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. And chairman's replies to questions, if any, 5 minutes for that. Second, the candidate's presentation providing an overview and findings of the research, 15 minutes for that. Then, questions to the candidate regarding the presentation, no more than 2 minutes per question. Fourth, the candidate's replies to the questions, 5 minutes for all. Then, a report on the thesis. The board members will be taking the floor in turns to provide their reviews and questions to the candidate for the degree. Ten minutes per speaker. Then, the chairman's report on the thesis. 10 minutes for that. The candidate's comments about the reports on the thesis and replies to questions, 20 minutes for all questions. Next comes open discussion. Anyone present at the defense may state their position or ask questions on the thesis. On the topic of the study, 2 minutes per speaker. And at that, I kindly ask you to fill in the registration form if you want to ask a question and introduce yourself before I give you the floor. And then the chairman will ask the questions submitted during the broadcast via our website. Then the candidate's replies to the questions, 2 minutes per question. Then the presentation of candidate's thesis supervisor, 3 minutes for that. Then next comes a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense is not broadcast. Then comes open balloting, vote counting and recording of the results in the protocol. Then we're going to make a decision on whether to confer the academic degree or not. And finally, we'll listen to the candidate's closing speech, 2 minutes for that. Distinguished colleagues, any questions or comments on our agenda? If there are no objections, let us proceed. But before we do that, I kindly ask you to switch off the sound on your mobile phones. Yes, dear colleagues, which camera is shooting? Yes, Alexander, everything is okay, by the way. The speaker is not using the microphone. Okay, dear colleagues. A short report of the chairman. The thesis by Liliya V for the academic degree of the Candidate of Sciences in Chemistry, specialization physical chemistry, is titled Synthesis, Physico-Chemical and Catalytic Properties of Perovskite-like ferrites, cobaltites and manganites of Getalenium and Reactions of Petrochemical Synthesis and Ecology. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued March 17, 2021, number 1953/1. Ms. Yafarova has prepared her dissertation at St. Petersburg State University, and Irina Zvereva, Doctor of Sciences in Chemistry, Professor of the Chemical Thermodynamics and Kinetics Department of St. Petersburg State University, is the Thesis Supervisor. 7 published works describe the research findings. There are no papers published in peer-reviewed journals recommended by the Ministry of Education and Science, and 7 papers published in journals indexed in Web of Science and Scopus. The candidate has submitted the full set of documents to the academic secretary. The above-mentioned documents comply with item 12 of section 3 of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University. And all the documents submitted, as far as I'm informed, meet the requirements and are found in the certification file. And the curator of the defense, the member of the Department of Dissertation Board Support, has all the copies. And before I give the floor to our candidate for the degree, dear colleagues, I would like to ask if there are any general questions to our candidate for the degree, and is there need to consider the full list of documents submitted by the candidate for the degree? No need for that. Okay. Then the short report by our candidate for the degree, 15 minutes for that. Liliya, please, you have the floor. Liliya, have you heard? Yes, please turn on your presentation and you can start. Hello, distinguished members of the board and listeners. I would like to deliver a report titled Synthesis, Physico-Chemical and Catalytic Properties of Perovskite-like ferrites, cobaltites, manganites, and gadolinium in Reactions of Petrochemical Synthesis Reaction. Catalytic reactions are in the basis of many petrochemical and chemical industry processes. I beg your pardon, do you hear me? Yes, we do hear you well. Okay. Regardless of the advantages, traditional catalysts have certain drawbacks that are associated with high cost of noble metals, low thermal and chemical stability, low stability to carbonization, and deactivation of the surface. Therefore, currently one of the main goals of the development of chemical industry is the search and the development of highly active and stable catalysts. Oxides with perovskite structure, thanks to high thermal stability, the opportunity to regulate physical and chemical characteristics, and low cost, are considered as an alternative to traditional catalysts for many industrial processes. And one of the advantages of perovskite-like oxides is the opportunity to create a broad spectrum of compositions due to full or partial, and also isovalent and non-isovalent substitution of cations A and B with the preservation of structure. This allows to regulate stability of the structure, electronic oxidation reduction, and superficial characteristics of complex oxides, and also create novel functional materials. Regardless of the fact that perovskite-like oxides have already shown that they are active and stable catalysts for many catalytic processes, there were no comprehensive studies on the impact of content, structure, and oxidation reduction characteristics on catalytic activity, stability, and selectiveness. So such studies are quite scarce. Thus, the goal of this work is to optimize the method for obtaining ferrite, manganite, and cobaltite of gadolinium in solid solutions. And we also consider the synthesis of Fischer-Tropsch, and also we consider Zolgel method. The object of the study are perovskite-like oxides, ferrite, manganite, cobaltite of gadolinium, and solid solutions that crystallize in different structures. The synthesis of complex oxides is carried out using the Zolgel method, and on the slide you see the basic stages of the synthesis of the studied oxides. And one of the advantages of the devised method is the use of small number of operations, relatively low temperatures, and small time of thermal processing. The devised methods are protected by 2 patents of the Russian Federation. Phase content of perovskite-like oxides before and after the catalytic processes is studied using the method of powder X-ray diffraction. Elementary content is defined by the method of atomic emission spectrometry with inductively coupled plasma. The content of surface is assessed by X-ray photoelectron spectroscopy, and we also use the SEM and BAT methods to study the morphology. Oxidation reduction characteristics are studied by the temperature programming reaction. Simultaneous thermal analysis combined with mass spectroscopy is assessed to is used to estimate carbonization level, and catalytic characteristics are studied in the processes of Fischer-Tropsch and dry reforming of methane. The results of the study of phase content demonstrated that the device method allows to get single-phase oxides, and all diffraction peaks are associated with ferrite, cobaltite, manganite of gadolinium, and their salt solutions. The specific area surface was assessed using the BAT method. Ferrite of gadolinium has the highest value, and other complex oxides demonstrate rather similar results. And relatively low values are explained by heating temperature. And at the same time, the value of surface area were higher for oxides than for similar ceramic method compounds. And we also use the same method to study morphology, and all the complex oxides demonstrate similar homogeneous volumetric rough surface formed by particles of different size and form. And in order to study the content of the surface, we used X-ray spectral analysis, and we carried out elementary mapping of the surface. The results show that gadolinium, ferrium, cobalt, and manganese are evenly distributed, and their content is close to theoretical values. The results of X-ray photoelectron spectroscopy allowed us to define the surface content and to specify cations, and it was established that metals in those compounds are in heterovalent state, ferrium +2 and +3, and the same is true for cobalt, and for manganese it's +3 and +4. The temperature programming reactions and X-ray phase analysis showed that the reduction of catalysts takes several stages, and it is defined by the nature and the level of metal substitution in B position. And it was established that the increase of the cobalt share in studied compounds lead to a drop of temperature of reduction and additional mobility of oxygen and oxidation reduction characteristics, and this promotes the increase of catalytic activity in oxidation processes. The increase of manganese share in solid solutions lead to an increase of thermal stability of the oxides. Dry reforming of methane is one of the most important chemical reactions applicable for industrial hydrogen and synthesis gas acquisition. And during the recent years, this method is widely studied due to environmental aspects. For example, they use greenhouse gases as reagents like methane and carbon dioxide, and it allows to get synthesis gas with low relation of hydrogen to CO, and it makes it more preferable using Fischer-Tropsch reaction. And this synthesis is a catalytic process of turning synthesis gas into hydrocarbons and spirits that could be later on turned into ultra-pure fuels and lubricants. In the recent years, the interest to Fischer-Tropsch synthesis has grown significantly due to the opportunity to produce synthetic motor fuels with the use of alternative energy sources as raw material. The study of catalytic characteristics of the perovskite-like oxides was carried out in flow catalytic installation with an atmospheric pressure. This installation scheme and the conditions are given here on the slide. And on the next slide you see the results of the study of catalytic characteristics of cobalt-substituted ferrites in dry reforming of methane at 750, 950 degrees Celsius. Regardless of the fact that for all compounds the catalytic characteristics grew with the rise of temperature, we observed certain differences in catalytic characteristics of perovskite-like oxides. For gadolinium ferrite, the conversion of methane carbon dioxide made up 45 and 60 degrees, and the carbon monoxide and hydrogen yield reached 41 and 24% accordingly. When we substituted ferrum with cobalt, we've seen the rise of catalytic activity of gadolinium cobalt 0.5 and ferro 0.5 and 0.3 demonstrated the drop in temperature of the process by 100 degrees Celsius, and full substitution by cobalt led to even higher drop of the temperature of the process, and the conversion values of methane and carbon dioxide, the yield of carbon monoxide and hydrogen has increased, were several times higher than general values on simple oxides. And when we administer small amounts of cobalt and we see the formation of solid when we see solid solutions, there is still activation of hydrogen, and the growth of energy barrier is compensated by pre-exponential factor value. And the growth of logarithm that characterizes the number of active centers is associated with an increase of selectiveness in hydrogen. And for carbon monoxide, there's no similar correlation. And this confirms the fact that in the centers of these oxides, we have the adsorption of carbon oxide. Dry reforming of methane, a reaction with manganese containing perovskite-like oxide, showed that when there is a rise of manganese in solid solutions, we see a drop of catalytic activity. And for samples with non-stoichiometrically substituted ferrum, with manganese, we see a growth of selectiveness for hydrogen and selectiveness values for this type of gadolinium with manganese, ferrum 0 and 0.3 reached 80%. And also our assessments show that the introduction of manganese and the formation of solid solutions lead to the growth of energies of activation in product formation, and at that logarithm values were higher in solid solutions than in ferrites and manganites of gadolinium. And the drop of speed of formation of hydrogen and CO can be explained by energy factor and also by differences in coupling energy. Manganese-containing ferrites were studied as catalysts for Fischer-Tropsch process. And on the slide here you see the results of study of catalytic characteristics in the temperature range from 250 to 450 degrees Celsius. And as it was expected, the level of conversion grows with the growth of temperature. For studied oxides, it's within the margin of 50–70%. And the best values of conversion of carbon monoxide were demonstrated for manganite. And the major products of this process were hydrocarbons with C1, C6, and among them we have methane, ethylene, propylene, butylene. So those were the basic ones. And the rise of manganese leads to a rise of selectiveness of the process to light olefins C2, C4. And in ferrite of gadolinium, some selectiveness made up 25–30%. And for samples with a prevalence of manganese, it reached 80%. And the study of catalytic activity of perovskite-like oxides that contain cobalt in oxidation of soot reactions demonstrated that the studied oxides have catalytic activity and allow to reduce the temperature of soot oxidation. And it was established that catalytic activity of these compounds rises with the increase of cobalt content, and it correlates with the reaction capacity of oxygen and perovskite-like oxides. The best activity of gadolinium ferrum 0.3 can be associated with the highest specific surface area of the sample due to denser contact between the catalyst particles and soot. And in conclusion, I would like to mention the stability of the developed catalysts. In order to obtain full understanding of phase changes that happen during this catalytic experiment, we held X-ray phase analysis. And on the slide you see the results of the study of the phase samples after the study of catalytic characteristics at 950 degrees Celsius during 120 hours. And according to the results that we got from ferrite, we don't see the phase content change, and it is associated with a high stability of this compound, and it is supported by the results of thermoprogramming reduction reaction. And cobalt-containing perovskite-like oxides demonstrated rather low stability, and after catalytic tests, we've seen partial destruction of the structure and the formation of certain oxides, the ones that you see on the slide. The results are supported by the results of kinetic studies, and they confirm the mechanism of the process, according to which the process of dry reforming of methane forms intermediate carbonate complexes, and then we have reduction with radicals C, CH, and hydrogen. We have the formation of atomic hydrogen here and radicals CH, and such. In such a way, the chemosorption processes happen on centers of different nature. And the formation of superficial carbonates happens on gadolinium atoms, and the formation of atomic hydrogen and CH radicals happen on ferrium, cobalt, and manganese atoms. Studying of the surface of catalysts after catalytic tests demonstrated that the change in morphology associated with coking of crystallites happen during high temperature processes. And we have not just this coking on the surface, we also see the filamentary-like structures. And according to elementary analysis, these filamentary structures are represented by carbon. And during methane conversion, the coke formation is one of the key reasons of deactivation of the catalyst. According to the temperature range of such studies, the formation of carbon happens due to some side processes, for example, the breakdown of methane and Boudoir reaction. According to the results described in the literature, at temperature below 400 degrees Celsius, we see the incineration of amorphous carbon, and it leads to the formation of synthesis gas. At high temperatures, we observe the incineration of filamentary-like carbon that leads to deactivation of the catalyst. And these values of carbonization of the surface are rather low compared to the ones described in literature. And this demonstrates the high stability of the developed catalysts. High stability to deactivation of the surface. And on the slide you also see the results of the phase content study for manganese-containing ferrites after Fischer-Tropsch process. This data were obtained after 48 hours of testing at temperatures 250-450 degrees Celsius, and the results show that for gadolinium ferrite we saw no phase content change, and gadolinium manganese ferrium O3 demonstrate partial destruction of the structure, and we also see diffraction peaks characteristic for gadolinium manganite, gadolinium oxide, and ferrium 2 oxide 3. For other substances, we see no change in phase content. Microphotographies of the surfaces of oxides after catalytic tests demonstrate the change of morphology, and we see the coking of the surface and aggregation of catalyst particles. Energy dispersion X-ray analysis showed that on the surface of catalysts after catalytic tests, we see carbon that is evenly distributed on the surface of the studied catalysts. And here on the slide, just as an example, you see the curves of thermogravimetric analysis of gadolinium manganite that demonstrate insignificant loss of mass, roughly 0.5%. And this demonstrates low level of carbonization of the surface. Similar results are observed for all the studied substances of this series. Thus, They studied perovskite-like ferrites, cobaltites, and manganites of gadolinium, and their salt solutions demonstrated unique catalytic and functional characteristics, and they are the promising materials for different heterogeneous catalytic processes in petrochemistry and environmental catalysis. Thank you so much. So, distinguished colleagues, questions if there are any? Yes, Alexander? Liliya? I would like to say at once that I have a positive review overall for the thesis, and when I'm going to read this review, you'll learn about it. But right now, I'll have some serious questions, because you represented the work in physical chemistry. And I haven't seen these elements of physical chemistry in your case. And I have the following arguments that I'm going to give you in my review. But right now, I would like to ask you certain questions, extra questions. For example, you mentioned that catalyst characteristics, it's not that clear. You're talking about catalysis activity that's growing or going down. This measure of catalytic activity was not represented in your report. And you say catalytic characteristics are growing along with temperature rise, but the temperature is growing and the speed of reaction grows as well. Could you divide it and finally give it as an equation for speed? That's the first question. And then I'll ask the following ones. Yes, Liliya, please. You can answer. Yes, Alexander Matveyevich, thank you very much for the comment and for the question. Indeed, one of the goals of this thesis was to study and assess the catalytic characteristics, and I understood the assessment of selectiveness, speed of formation of the products, and the level of reagent use. Maybe I should have given a detailed characteristic. Maybe I should have given more detailed study in this regard, but we did these attempts, and the problem was that we are working with very complex systems. And in our case, it was very hard to assess the orders of reactions due to a lot of reactions that happened at the same time. Yes, it's clear that the question is a complex one, but you should have made certain attempts and assessments, and as Frankel said, a good physical model is a caricature for reality. You should have chosen certain points and tell about them. For example, you talk about selectiveness on hydrogen, that's slide 14. What do you mean by that? This as letter, is it a formula? So what? What does this formula mean? The correlation of masses. Yes, the correlation of the content of hydrogen for the sum yield of the product. And what's this sum yield of the product in this case? In this case, we are talking about dry reforming of methane. We're talking about carbon and hydrogen. Yes? Igor, can I ask you another question? Okay. Yet another question. When you say that on the surface there is there are heterovalency states, and you have ferrum plus 2 and plus 3. Can you differentiate how many ferrum plus 2 and how many ferrum plus 3 atoms you have there? Yes, in the text of the thesis, I give the calculations. No, we are not going to consult the text right now. Could you say it right now? Well, on the surface of the catalyst, we see the prevalence of ferrum plus 3. So there's a prevalence. Okay, and what kind of prevalence? 51 to 49? So, is it a 2 times prevalence, 1% prevalence? What kind of prevalence is it? No, that's... Well, unfortunately, right now I won't give you the exact figures, but no more than 10% difference between them. Okay, I have other questions, but maybe maybe Nikolai or Igor want to ask questions, and other colleagues. So I won't ask these questions right now, but I'll ask them later on. Okay, colleagues, Saratov, Minsk. Any questions from? Yes, Igor. Let me ask a question as well. I have several questions as well, and I'll start with the simplest one. Lily, could you tell me why did you decided to choose gadolinium? Because we've been working with a conversion catalyst, and we use gadolinium containing substances. Why did you choose gadolinium? Yes, thank you very much for the question. Indeed, the choice of gadolinium is explained by the most recent studies in the development of catalysts for industrial processes that show that a catalyst doping with small amount of gadolinium compounds lead to an improvement of catalytic and functional characteristics. And yet another advantage of gadolinium is its low cost compared to other rare earth metals. And in this case, it allowed us to reduce the cost of the catalyst. Have you thought that maybe it's associated with electron construction of gadolinium? Yes, certainly. Yet another reason of choosing gadolinium is explained by this fact. Okay. Let me ask yet another question. Could you please tell me, you studied the catalytic activity of the synthesized perovskite-like catalysts. That's very important, sure enough. Could you please tell me, have you managed to consider such issues like the influence of contact time and the level of transformation of methane in dry reforming conversion? Yes, we've considered this issue, and also such studies were held not just for our catalyst but also for comparison catalysts, simple oxides and silicon dioxides. We've took this point into account and we held such studies. And what did they show? They showed that the contact time has no significant difference, but we saw the impact of preliminary treatment, and to this end we conducted studies of thermally programming reactions. Okay, I would agree with you if we were talking about oxidation reaction, because that's a quick reaction. But if we're talking about methane conversion, and such molecules are quite stable, in order to achieve high conversion of this molecule, we need a rather lengthy period of contact. What time of contact did you consider taking into account the speed of molecule submission to the reactor? We experimentally secured the speed at the level, at the same level, at the set level. That's one. Well, unfortunately, I don't give it here. That's 1 liter per hour. And basically, based on that, we considered this influence. Okay. And yet another question. If we talk about volumetric speed, then it should be no less than 1 hour. Otherwise, how are we going to analyze it? And agree, yet another question, the last one. So could you please tell me, we all know that it's no less important to consider not just the content of the catalyst, but also the specific surface area. So how do you associate the surface area of the catalyst with catalytic activity? In this methane conversion reaction and in Fischer-Tropsch synthesis. Yes, thank you so much for the question. Indeed, the specific surface area is used to assess catalytic characteristics of catalysts, but in our case, all the studied compounds, they have similar, rather close values of specific surface area. Therefore, in analysis of the obtained results, we did not see any input to the characteristics. Okay, and then you have a question: why is this difference between the activity of catalysts? Yes, therefore we considered active centers, the state of metals that are included in the catalyst content. Thank you so much, Igor. I'm satisfied with the answers. Thank you. Other questions, colleagues? Maybe I. In your thesis, you state that there's an increased content of ferm that reduces catalyst activity. Could you explain why? Yes, indeed. I understood what comment you're talking about. One of the members of the board had a similar question. And here we are talking not about the reduction of catalyst activity. Here we consider the influence of ferm on a reduction process. And judging by the results of thermoprogrammed reactions, we see that the administration of ferm actually inhibits the restoration of cobalt. And on this specific scheme, you see that the restoration temperature shifts to high temperature range, and also the volume of hydrogen that is spent on that also drops, and this demonstrates the ferm inhibition activity. Thank you. Any other questions? Okay. Thank you. Dear colleagues, now I need to say that we have some external reviews on the thesis from Alexander Lisitsyn and Vladimir Cherepanov. All the reviews that were submitted by the members of the board and two external reviews were downloaded to on the St. Petersburg State University website. Everyone could get acquainted with them. Therefore, I'll read two external reviews, and then we'll shift to our reviews. And I ask you at once to be quite specific, not to take too much time, not to read for too long, but to concentrate on the positive points, and on. You can also give your remarks and ask your questions. So the first external review comes from Vladimir Cherepanov, Doctor of Sciences in Chemistry, Professor of the Institute of Natural Sciences and Mathematics of the Yeltsin-Ural Federal University. And in the beginning of the review, there are the good words to our candidate for the degree, that's quite a relevant work. And when Vladimir read the thesis, he had several questions and comments, and I'll read them out. Did the author use cobalt oxide, cobalt 203, that could be obtained in strict oxidation conditions? And there was a question on the inhibiting role, but we already answered it. The content of beta-2 in the increase of cobalt content is a mistake, and maybe the author referred to vacancies in sublattice of oxygen. Fourth, in order to assess the activation energy for the processes, on page 83, the author provided dependencies, but these images were not given in the thesis. Therefore, it's hard for the reader to assess the level of ionization. The list of literature sources is not quite correctly documented, so you provide the information on publishing houses and so on for no reason, and also you provide volumes in Russian. So I offered to answer the questions separately so that it would be clearer for us. so it would be clearer for us to understand the answers. So please, Liliya, you can answer Vladimir's questions. Yes, thank you very much. The answer to the first question on the use of cobalt oxide, indeed. In order to use temperature programming restoration method, we used the cobalt oxide 3, and this compound was provided by colleagues from the Department of Inorganic Chemistry of St. Petersburg State University. And let me not repeat this answer to the second question. Yes. And next remark. Well, I agree with all the comments that Vladimir gave, and I'm grateful for his review and for his comments and for the questions on my thesis. That's it. Yes, certainly Vladimir said that he liked the thesis, and he believes that Ms. Liliya V deserves the degree of the candidate of chemical sciences. Okay, dear colleagues, next external review comes from Alexander Lisitsyn that represent Federal Berezkov Institute of Catalysis of the Russian Academy of Sciences, and in the beginning of the review he writes that the work is quite relevant. He provides describes the major advantages of the work, and as for the questions for discussion, Professor Lisitsyn writes the following things. First, we can't agree with the words on page 25 that hydrogen absorption on metals of 7th group, I believe he refers to 8th group. So, unlike CO absorption, chemosorption of oxygen does not introduce significant impact in the Fischer-Tropsch process, and we can just agree with the fact that this impact has a higher role, and this is described in Article 111. Second question, this data on elementary content show increased level of ferrum in the sample in gadolinium, cobalt, and according to the author, it's likely associated with the impurity phase of ferrum, and this is dubious because even a full breakdown of this compound up until ferrum oxide and cobalt oxide can't lead to such an increase of ferrum content, 13% compared to the expected 5.2%. And just to confirm my opinion, I give you the data. And according to the opinion of our author, in this case we are dealing with a phase of ferrum oxide on the surface of the particles, and this is shown by X-ray photoelectron spectroscopy. Third, the speed of hydrocarbon formation is different in 3 or 8 times. And the last question, when calculating the activation energy and pre-exponential factor, did you take into account the diffusion limitation opportunities going through kinetic area? So thank you for the questions. As for the first question, indeed, there was a misprint. As for the second comment, I agree with it. As for the question on the difference of values on the above-mentioned images and table, the difference in values can be explained by a misprint in the line that describes the table, and I give not the data for solid solutions. And in the table I gave the results for ferrite and for manganite of gadolinium, and for solid solutions as well. As for the next question, the data was taken into account, and as for other comments, I agree with them, and I also thank Alexander for attention to my work. And yes, the conclusion is quite positive, and Professor Lisitsyn believes that you deserve the academic degree of the candidate of sciences in chemistry. So, dear colleagues, now we shift to our reviews. So we can read these reviews as we like. And first of all, I would like to give the floor to our colleagues that are working remotely because they decided to join us. They're far away from St. Petersburg. Raisa, if you don't mind, I would like to give the floor to you first of all. So please turn on the microphone. Yes, thank you so much for this opportunity. Unfortunately, we're not in St. Petersburg, not with you. But still, as for the work by Liliya V on the topic the synthesis, physico-chemical and catalytic properties of perovskite-like ferrites, cobaltites and manganites of gadolinium in reactions of petrochemical synthesis and ecology is certainly a very serious work, and the relevance is associated with the fact that chemical technologies and industrial ecology have a lot of catalytic processes, 90% of them. Therefore, the development of catalysts of new generation is of particular importance. And regardless of the fact that perovskite-like structures and catalysis are quite popular, we still have no methodology for the development of such catalysts that would be active in reactions and in the processes of petrochemical synthesis and in ecology. And I believe it's of particular interest to consider the methane catalytic transformation, because the transformation of hydrocarbons, that's a huge problem of petrochemical synthesis, and for methane it's particularly true. So the work of Ms. Yafarova is really a step forward in the technology of developing of catalysts of certain type. Multi-component catalysts, and here I'm referring to this broad content when we have several metals and when we have a rare earth element in the structure. Certainly that's quite a complex issue, both in the synthesis and in the definition of the role of these catalysts in all kinds of reactions. So basically, the novelty and the relevance are not questioned at all. Practical importance stems from those reactions that are described and studied in this work. Fischer-Tropsch process is the process that we've known for a very long period of time, but up until now it's not completely clear because a lot of catalysts were developed for this process. But still, Fischer-Tropsch process is the process of the future, and then in Russia it's not that widely developed. That's not associated with the fact that we are lagging behind. It's associated with the fact that we have a lot of hydrocarbon raw materials, and Fischer-Tropsch synthesis for us it's not that important today. And as for other countries that are not as rich in hydrocarbons, that's of particular importance. And therefore the work of Liliya V is quite important, not only in Russia but also across the world, because catalysts for methane conversion and Fischer-Tropsch synthesis, I believe these are the catalysts of the future. Now I would like to say a few words about being, a bit envious about this opportunity to study the catalysts. And not just the synthesis. Synthesis is quite simple and cost efficient. But the fact that the author managed to trace the formation of catalysts during the synthesis, and we are saying that catalyst activity is associated not just with the content, it's associated not with specific surface area. And this was, by the way, well shown today. It is also associated with energy state of the surface, and that is of particular importance. Therefore, the combination of those methods that we've heard about today and the ones that are given in the work, those mutually complementing methods that show the influence of surface state, the synthesis of perovskite-like structures on the catalytic activity in similar reactions. So that is really an advantage of this work. And the fact that this work is so well represented, 7 articles in leading international journals cited on Web of Science and Scopus, it demonstrates the importance of the work, the interest, the novelty, the practical value of this work. And sure enough, that's a huge advantage in the of this work, and it shows how important it is. And once again, I cannot but mention that the specific area and phase state and the elementary content and also the state of atoms and the morphology of the surface, these all are the important components of the work that allows us to develop the methodology of catalyst formation, if we talk about perovskite-like compounds in catalysis. And unfortunately, like any work, the work has certain issues to be raised, and I believe these questions would be of interest to the candidate for the degree. Let me read the questions. As a result, we see the huge experimental material, and we see the connection of catalytic activity and the content. Being based on this data, is it possible to provide recommendations for the search of more active catalysts, or give the processes, take the processes for which we can apply the developed catalysts? So that's about the practical development of this work. The second question is dealing with the fact that today we've already heard it. We heard about linear Arrhenius equation, dependencies of energy of activation in calculations from the logarithms of and the author has already answered this question. Third question, how does this flow speed influence the level of conversion? And you answered this question as well already during the defense procedure. Second question, did you have any attempts to define the order of reactions on reagents for certain systems? Fifth question, fortunately, during the discussion of results of catalytic experiments, you did not take into account the data on specific surface area, and this complicates the comparison of samples. And the last question, regarding the results of chromatographic analysis, I would like to specify how did you carry out the analysis, in what conditions, and what are the specific results that you managed to obtain. Overall, the questions and comments do not compromise the high value of the work, and the thesis by Liliya Yafarova, titled Synthesis, Physico-Chemical and Catalytic Properties of Perovskite-like ferrites, cobaltites and manganites of Getalenium and Reactions of Petrochemical Synthesis and Ecology, meets the requirements of St. Petersburg State University on the procedure of granting academic degrees, and Ms. Yafarova deserves the degree of Candidate of Sciences in Chemistry in specialization physical chemistry. And Article 11 of the above-mentioned order is not violated. Thank you so much. Okay, thank you. Liliya, you can answer the questions. Raisa Ivanovna, thank you so much for the kind words and for the questions. As for the issues about the processes that can be used, for example, the synthesis gas from biogas, and this process can be used in neutralization of exhaust gases, and this data can be used for the development and improvement of catalysts for petrochemical synthesis processes. And as for the second question, I've already answered it, as you mentioned. And next question on the influence of this flow speed. Indeed, the gas mixture flow speed has an influence on the level of conversion. However, when we held experiments, we maintained the speed level at the set range, and thus we minimized this impact. As for the attempt to define the order of reactions, indeed these studies were carried out, but the interpretation of results was complicated by parallel reactions, and this influences the accuracy of values. And as for specific surface area values, yes, the results of catalytic experiments were coordinated with these results. However, as all the studied catalysts demonstrate similar values, the specific surface area was not quite informative because there were no differences in catalytic activities that can be defined by not just specific surface area, but also by the change of nature of active centers. And then the comment about chromatography analysis. Indeed, unfortunately, in the text of the thesis, I did not give these results of chromatographic analysis of the product. However, the methods are described. I describe the process of, and also then I described the gas chromatography method. This chromatographer was equipped with 2 detectors, including the ionization detector. The division of compound was done on the columns. And as for other comments and remarks, I agree with all of them. Thank you, Raisa Ivanovna. Raisa, so are you satisfied? Yes, I am. And the questions that were voiced, I believe, they are fully answered by the thesis. Okay, thank you, Raisa. Now I would like to give the floor to Andrei Viktorovich Blahin. Thank you. I believe that the thesis and the report are quite good, like the report as well. Certainly that's a very impressive and very interesting work. As for the object of study, that's complex perovskite-like oxides, and also on the subject of study, physico-chemical characteristics. So this work can be a traditional work, as we do it in Belarus. This could be a traditional work on the synthesis study and chemical characteristics study, but this work has 2 major blocks. The first block is synthesis, mechanisms, characteristics, and the second block is the study of catalytic characteristics. And the unification of these 2 blocks, to my mind, gave a very good work. That's how I see it. And if we talk about the relevance of the study, certainly these are novel results, and they were tested quite well. 7 publications. Yes, 7 publications in very good journals. 2 patents, although I did not get it. In the thesis you write about 1 patent, and in the report you mentioned 2 patents. So how many of them do you have? But I believe that you had 2 of them. Yes, 2 of them. Okay. Yes, I fully support this work, therefore I'll shift to other remarks. So the first one, it's unclear how you define this correction coefficient to calculate the speed of hydrocarbon formation in table 2.1. In formula 2.2 you should have the final result, and the level of peak is not measured in square millimeters, and it's not recommended to use similar definitions for different values. And according to image 3.1, we believe that small loss of mass made up 2%. Third question, it's unclear why you give the content of manganese, and in table 3.6 you give manganese because you give cobalt, because initially these elements should not be present. And fourth question, the relation of chemical isotope oxygen to lattice oxygen in this transition of ferrite to cobaltite of gadolinium first drops and then stabilizes at the level of 3 samples. Can you explain this dependency? Fifth question. In table 3.10, you incorrectly gave the processes for the second and the first peak. And in tables 3.12, 14, and 16, you should have provided errors, the energy of activation, a logarithm of pre-exponential factor, that are explained by a coefficient of linear equations, because without them it's hard to assess the studied values in complex oxides. But these comments are not of principal character and they can't influence the overall high appraisal of this work. And the thesis by Liliya V is a finished qualification study, and it demonstrates that the author mastered both experimental and theoretical methods at the necessary level to plan scientific studies. And this corresponds to the requirements of two candidates of sciences and chemistry. Therefore, the thesis by Yafarova meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And Ms. Yafarova deserves the academic degree of the candidate of sciences in chemistry in specialization 020004 physical chemistry. And Article 9 and Article 11 of the above-mentioned order is not violated. And in conclusion, I would like to say a few words about complex perovskite-like oxides. Many works, and on the slide we've seen it, that we do hold such studies as well on physics and chemistry, but we use those oxides for electronics, and here use them as catalysts. And I'll be pleased to listen to Alexander Matveyevich about how this dissertation complies with the requirements of physical chemistry. But to my mind, this thesis, as presented, complies with this specialization, physical chemistry. Yes, thank you. Thank you, Andrei. Please, Liliya, you can answer the questions. Andrei Viktorovich, thank you so much for your remarks and for your attention to my work. As for the comment on the text of the thesis that I give, just one patent. Yes, the second patent was obtained March 17th, therefore it was not included in the text of the thesis. As for correction coefficients, those were defined by the method of absolute calibration. The issue on the mass loss, according to the results of thermogravimetric analysis for gadolinium ferrite, made up 0.2%. And as for the comment on the fact that in table 3.1 I should have given manganese content, I shouldn't have given manganese content, yes, I agree with that. It is not that convenient for analysis. As for the dependencies of relations of chemically soaked oxygen to lattice oxygen during the transition from ferrite to cobaltite, unfortunately for us, this question is not quite clear yet. As for other comments, I agree with them. Thank you so much. Okay. So are you satisfied with the answers? Yes, I am. Thank you. Now I would like to give the floor to Nikolai Charikov. Thank you, Igor. If you don't mind, I won't dwell upon the formal details. In my review, I described the goals, the novelty, the importance. I described the provisions brought for the defense and also the a list of publications, and all these characteristics comply with the requirements. The requirements for this academic specialization of physical chemistry. And I would also like to mention the high technological importance of the work for the development of new methods of synthesis. And I believe we can just welcome it. Indeed, these technologies is the transfer of methane using partial oxidation method into low-octane gasoline or into diesel fuel or into methanol, and then this process can be shifted to high-octane gasoline. So that's a multi-billion process, billions of dollars a year, and saying that countries that have a lot of hydrocarbons develop such plants, it's not the case. You should take into account that there are countries with a lot of gas but a limited amount of oil. That's Southeast Asia, so these plants are working there because they have a lot of gas. And as for gasoline, it's quite limited and it's quite costly, therefore it's efficient for them, but it's still important when the oil prices are higher than $50 per barrel. These plants generate revenue. So now I'll shift to questions, if you don't mind. For some questions, the author has already answered. Some questions were already answered, but I'll read all of them. So this idea of replacement of lanthanides in catalytic perovskite-like structures by other rare earths, for example, gadolinium, is a productive idea and allows to increase the variability of synthesized structures and their catalytic activity. These vice-valent solid solutions allow to expand the physico-chemical catalytic characteristics of synthesized structures, and therefore we have a natural question. Why did you choose gadolinium from all rare earths as a basic element and that you use in perovskite-like ferrites, cobaltites, and manganites? So you've already answered this question. And second question, on page 44, you say that a specific surface area was defined by low temperature adsorption of nitrogen using bath method using quadrisorb C. And this the question, how accurate were these data that you got according to heat absorption of nitrogen? The thing is that when we calculate the surfaces of such absorbents, for some sorbents, it's not accurate. For some sorbents, the size of molecular pad is defined, but not by the size of the molecule, but rather with the topography of the sorbent. And molecular pads of nitrogen molecule increases when we replace OH group with hydrocarbon radicals, and that's a well-known fact. And using such non-polarized adsorbents as argon and krypton would allow to avoid this inaccuracy. But specific surface area is, is rather large. Okay, I'll try not to be too close to the microphone. And there's yet another question. How accurate is the definition of distribution of these pores inside? I'm not talking about the average size of the pores. Basically, to the different parameters are used here. Third, defining the elementary content on page 53 for salt solution of gadolinium cobalt ferrum 03. The content of ferrum makes up 9%, and that's higher than the content for solid solution. And if we take into account the presence of impurity phase of ferrum oxide, it's hard to explain this fact. Second question, the thesis by Liliya V is written quite well. However, there are some style failures. I'll give you just several of them. On page 23, you write that in the process of Fischer-Tropsch, huge influence on the speed of formation is explained by the type of catalyst, but that's a well-known fact that we've known for 100 years, and you provide a reference for the review of 2019 on cobalt-containing catalysts. And on page 25, we read adsorption of hydrogen on metals of 7th group. I believe you referred to 8th group, but you've already answered that. And on page 30, Pascal is written from small letter. And on page 47, this mistake in the definition of component. So that's a well-known note that we are referring to the accuracy of maintaining temperature. If you're going to carry out chromatography at 24 or 25 degrees, that has no impact whatsoever. And on page 53, you write that chemical content of the compounds was studied using the ICP method. Method of inductively coupled plasma is the method of sublimation, and it's quite actively used in emission spectroscopy and mass spectroscopy. But that's not the method to define the chemical content, you know. But still, the thesis by Liliya Yafarova complies with the requirements of the order on the procedure of granting academic degrees, and Ms. Yafarova deserves the academic degree of the candidate of sciences in chemistry and physical chemistry, and Articles 9 and 11 are not violated. Thank you, Nikolai. Liliya, please, you can answer. Yes, thank you so much for the questions and for the comments. As for this question on the choice of gas and solvent, really I agree with your comment. The choice of gas absorbent can influence the value of surface area, but the definition of specific surface area is a standard method, and it's widely used to assess the surface area for different materials, including catalysts. Therefore, this method was chosen as an instrument to study the morphology of the surface. And unfortunately, the compounds have rather insignificant values of specific surface area. Therefore, in this case, the distribution of pores and the size was quite hard to define. As for the question on the content of ferrum in solid solution, indeed, there is an increased ferrum content that can be associated with an oxide phase on the surface of particles, and this is supported with data of photoelectron spectroscopy. And as for other comments, I agree with them. Thank you so much for the attention that you've given to study my thesis. Yes, I'm fully satisfied with the answers. And now I would like to give the floor to Alexander Toyko. Thank you, Igor. I won't repeat all these comments, but indeed, we have a kind of polemics, and we asked these questions. Well, I did not mention that this work does not comply with the requirements, but I said that in the report you should have given more attention to physical chemistry, and if you disagree with me, I will be quite active in our dispute. You see, perovskite-like oxides, and here we're referring to ordinary perovskites, layered structure perovskites, and so on. Raisa mentioned, and Raisa says that perovskites were used for a long period of time as catalysts, but now we see a new generation of catalysts that are based on the application of perovskite-like oxides. And this work is quite interesting. You know, this question, why gadolinium and nothing else? But I remember this story, why Gibbs energy but not other compound energy? So, you know, we know that Lily is quite experienced in the field, as well as her academic supervisor. Some chose gadolinium, some chose something else, but that's the expansion of databases, better understanding of physico-chemical material, and that's it. So perovskites, they're quite in fashion today as photoactive materials. Why can't we use them as, for example, Liliya used them? So that's, you know, a huge scientific novelty, And I also have some compliments about the theoretical value, practical value, but I believe we've seen these studies. And by the way, the work itself is quite large. And I can say that I've seen how Liliya worked, and I know how industrious she is, and she managed to achieve very good results during a limited period of time. She got a lot of results. And basically, if we talk about physical chemistry or solid-state chemistry, you had the department of the chemistry of solid state, and this classical monography, Ionics of solid state, that's a kind of encyclopedia, and Irina mentioned that as well. But it's overfilled with physical and chemical content. Therefore, we can't introduce certain divisions here and say that that's not physical and chemical study. Well, I'm not sure who I actually am, a physicist, chemist, or mathematician. Yes, I'm not sure who you are, indeed. Okay, certain comments for Liliya. So, I'm talking about physical-chemical content. The work, as a study of catalysts, should be referred to physical-chemical topic. Andrei, that's to you. And yes, he nods. And the physical-chemical part and quantitative interpretation of data are not enough. And we can mention the activation energy data. But other correlations, excluding such parameters like the order of reactions, and Larissa asked about that. For example, the correlation of thermodynamic and kinetic and kinetics. So you don't provide some quantitative dependencies, and this comment will be associated with the second comment. The second comment is as follows. It's unclear what... Well, I'm not sure that you should dispute that, Liliya. It's unclear whether you studied sorption characteristics of catalysts. Nikolai asked this question with sorption characteristics. And you said that the author studied them. So you don't see this dependency from dispersion. And you mentioned thermoprogram desorption of oxygen, and you can't associate this data with bad data, I believe. Third question. I've already asked it. What do you mean when you say catalytic activity? Basically, catalysis is a complicated thing, and our department, they tried to rename our department using this word catalysis, but we fought actively because catalysis as a science is something quite indefinite and broad. That's organics and inorganics. These are barriers between heterogeneous and homogeneous catalysis and so on and on. So, catalytic activity. Indeed, quantitatively, it's clear. There's equations on slide 14 when you use acid. So this equation is quite clear, though it has no sense in it, as a paradox. You need to think all the time what the author is referring to. Or maybe these quantitative characteristics are insufficient. For example, on page 101, you say the catalytic activity of the studied compounds is quite well correlated with the results of simultaneous thermal analysis. And on pages 41, 45, you say the studies took place in the resource center. That's a question not dealing with the scientific discourse, but that's a question to the candidate for the degree. Referring to the Lab of Catalytical Studies of the Tomsk State University. So it's clear that the author took part in these studies, but it's unclear how significant the role of the author was in these studies. And then there are certain style problems, but everyone is tired of such comments, I believe, because in order to define the phase, content, and structural data, this wording. There are a lot of funny stories about discoordination of wording, and you're referring not to the data but to characteristics and then to the data. So, however, this does not compromise the high mark. And once I heard that a PhD thesis should be a finished study, and that a doctoral thesis should not be finished and should provide further ideas. And the volume of work, the data, the test of results was quite, they all were quite good. Therefore, the thesis by Liliya Yafarova meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And Ms. Yafarova deserves the academic degree of the candidate of sciences in chemistry and specialization physical chemistry. That's it. Thank you. Thank you, Alexander. Liliya, please, you can answer this rather emotional remark. Yes, Alexander Matveyevich, thank you so much for your review, for your attention, and for this, indeed, emotional review. Well, no emotions. You haven't seen me emotional, you know. Yeah, well, anyway, I was quite pleased. Yes, as for the first comment, and all of your comments and remarks, certainly I agree with all of them. Maybe we should have carried out a more detailed analysis and interpretation of results. As for the study of sorption characteristics regarding gases that participate in these catalyst reactions were not studied, indeed, because at high temperatures the reactions give desorption, and at low temperature we have sorption of nitrogen, and the surface area is insignificant, and it means that our compounds as sorbents do not have good prospects for the future. As for the experiments held in the resource center, I participated not just in the planning and in the processing of results, but also in tests in X-ray, electron spectroscopy in some methods. And as for electron programming reactions, I held them independently at Tomsk and at our university, because I had an internship to Tomsk University with the support of mobility grant. And as for the comments on an accuracy and style, certainly I do have them. Yes, no need to answer them. Okay. This comment is always given in order to demonstrate that the opponent read the text quite attentively. Yes, indeed. Yes, and I can say that the work is a kind of pioneer work, therefore I don't agree with many answers. However, the young researcher has this right to have these independent opinions, therefore I am satisfied with the answers. Yes, there's a well-known saying that there are more questions than answers, and we're searching for new questions. Okay, thank you, colleagues. Now it's my turn to deliver my review, and therefore I remembered these words that everything was mentioned already. But as no one is listening, I'll start with the very beginning. Indeed, in all speeches, we talked a lot about novelty, about the object of the study, and about compliance with the specialization. Indeed, I believe that's a physical chemistry thesis, and it is a classical study of the triad of this content, structure, and characteristics. And this work successfully continues the works associated with synthesis and study of perovskite-like structures. And Irina has a lot of such PhD students on the department of Alexander Matveyevich. And indeed, colleagues have already mentioned the relevance, and I'll mention just one thing. This full solution of the important question is the study of physical and thermal stability of catalysts using the comprehensive study before and after the catalysis processes. And at that, the author studies the entire range of characteristic structure, morphology, electron states, chemical content, including the level of carbonization of catalysts and so on. And all the provisions that were brought for the defense, indeed, they are novel and quite beautifully presented in the thesis. And as other members of the board, I would like to read certain remarks and wishes. And they are as follows. Regardless of the huge literature review and exact goals, it's not quite clear why you chose this content of samples. Why did you choose these catalysts? If, for example, the choice of ferrum, cobalt, and manganese oxides is clear, these are quite popular catalytic systems. The choice of gadolinium is not quite substantiated, and all the colleagues referred to that. And taking into account the high practical value of this work and the efficiency of synthesized catalysts, we should have introduced some comparison with commercial, actively used catalysts, because I always say it in our department and in other, during other defenses, that we're working in a well-known sector, and we should show why our choice and why our results are more cost efficient, because that's always important to show. Taking into account the possibility of heterovalent states of ferrum, cobalt, and manganese, and the level of oxidation too, what roles are played by anion vacancies in oxygen that should be placed second? In order to study electron state of atoms, you used the X-ray photoelectron spectroscopy method. Did you study ferrum with Meß-Bauer spectroscopy and gamma resonance fluorescence without yield? Because this method is something that our faculty has. Fifth question. In the text you use this term ultra-disperse and nano-size powders, but you don't give the definition for them. Because under-red has yet another good wording that mankind would not face numerous problems if they would define the words correctly. And next comment. You don't give the errors in the analysis of experimental data, and my colleague have already mentioned that. And all these questions and comments do not compromise the overall high value of the thesis. And the thesis by Liliya V, titled Synthesis, Physico-Chemical and Catalytic Properties of Perovskite-like ferrites, cobaltites, and manganites of gadolinium and reactions of petrochemical synthesis and ecology, meets the requirements of the orders of September the 1st, 2016, on granting academic degrees at Petersburg State University, and Ms. Yafarova deserves the academic degree of the candidate of sciences in chemistry and specialization physical chemistry. Thank you. So, Lily, you can answer. Yes, Igor Vasilievich, thank you very much for the questions. As for the first question, I won't answer it. Yes, no need to answer the already voiced questions. As for the comparison with other catalyst systems, when we try to compare the results of catalytic experiments with commercial ones, the ones that are already in use, we face several problems. First of all, the comparison with industrial samples was impossible due to commercial secret of the producers. And if we compared low-temperature catalysts, it was hard because we didn't have full information on the catalytic processes and on the characterization of catalytic systems. Therefore, catalytic activity was compared with binary oxides in the conditions that are similar to the industrial ones. As for the study using X-ray photoelectron spectroscopy, these studies were held for some ferrum-containing samples, and the results of this spectroscopy support the results of Mesbauer spectroscopy. And in the text of the thesis, they're not provided, but they were provided in the qualification work of a PhD student. So there we studied layered perovskite-like structures of containing ferrum. As for the comments on the use of this ultra-dispersed and under-dispersed powder terms, I agree with your comment. This definition should be given because this difference in size is not defined, and in many sectors we have different interpretations. And according to the most widespread interpretation, submicron objects are those objects with a crystallite size from 500 nanometers to 1 micrometer. And ultra-dispersed objects are get this intermediate position. And as we studied complex oxides that demonstrate broad distribution of particles in size, that is why in some cases we use this term ultra-dispersed and in some cases nano-size powders. And I agree with other comments. Thank you so much. Distinguished colleagues, now I want to ask all the members of the board, is everyone satisfied with the answers? Yes? Yes? Okay. Yes, I'm satisfied. Dear colleagues, does anyone want to ask a question or to deliver his or her review on the topic? No, everything goes according to the schedule. Yes, I'm following the agenda. Now, I would like to give the floor to the Thesis Supervisor. Please, Irene, have the floor. Distinguished members of the board, do you hear me well? Yes. I won't talk about the work, though I would like to, because Liliya made a wonderful presentation about the topic. And I need to characterize her as a scientific worker and as a personality. Indeed, it should be mentioned that Liliya graduated from our master's course and PhD course. And her first education was in Saratov State University, and her diploma was prepared on the department that Larissa had, and that Raisa has. And as it was already mentioned by Nikolai in his speech, in the classical university, she got such a technological education. And indeed, it helped her and it helped us, because this study, or the study of practical processes with the application of objects that we previously studied for fission-Tropsch reaction, for reforming of methane. So it brought us to a new stage, not just thanks to the goal that she had, but also thanks to the fact that Liliya was trained well enough, and this allowed her to start working with these issues. And the kinetic studies were shifted to the next level as well, and a lot of new characteristics were generated, and the fact that she got compounds with high catalytic activity, that's answering the question of Alexander Matveyevich. It means that the high level of conversion, 99%, is secured, and that's great. Yes. But talking about Liliya, I believe you all saw that the volume of work is quite large, and I can say that just one graduate student helped her. Sometimes it may happen that a lot of students are working in one group, but Liliya had just one student, and all other results were received by Liliya. She is incredibly industrial, incredibly active, and communicative. So it all helped her to work and to take internships in the leading catalytic labs of the country, as well as in foreign countries. And in the end of the thesis, she mentioned the grants in which she participated. And the one that she got independently, these are several grants of the president and the government and the mayor's office of our city. And also there were internships in the University of Rostock, and also within the framework of mobility program under the Russian Foundation for Basic Research. And as Liliya worked for several years in our resource center, and as she understood the thermogravimetric methods quite well, and I'm not talking about thermoprogramming, restoration equipment, and she helped the entire university with it. When she arrived at Tomsk University, in which she studied oxidation of soot, Liliya really understood simultaneous thermal analysis, and I was really pleased that our representative could work so well and knew the methodology fully and was ready to work with it. So she can do a lot herself in answering questions. She said that she performed X-ray analysis. Yes, she did it herself. And finalizing, what do I want to mention? Igor mentioned that there are goals to study the stability of catalysts before and after. You know, few people decide to work on the issue because no one wants to work with catalyst after the entire process, because catalyst is applied on certain surface, quartz or silicium. And Liliya spent a lot of effort to break down this compound and to sort out the catalyst and to carry out all the studies. And gadolinium helped a lot here because it has 7 electrons. And that's a strongly magnetic substances. And she used magnets after synthesis. So that's a really painstaking work. And Lily is able to do whatever she wants. She's ready to resolve technological and preparation problems. So she knows all the processes quite well. She wonderfully worked with literature sources. She really understands how to work with literature, with technological literature. And that is why we managed to prepare documents for 2 patents during her work. And Liliya participated in the application process. She was the main contributor to this application process, and her training and her industriousness allowed us to perform this huge work. And in this regard, I'm grateful to Liliya for her contribution to the work of our lab. And finalizing, I want to say that indeed I pity that we did not manage to preserve Liliya in our ranks. Though Liliya is really the talented youth representative. But I believe we'll have it in the future, and I did not mention it that Liliya worked not just with her thesis, but she actively participated in the scientific work of the entire department, and she also worked on other grants, and she has publications, not just these 7 publications, but several publications on other topics as well. So that's basically it, what I wanted to say, and I hope that you, as well as I, believe that Liliya certainly deserves the academic degree of the candidate of sciences in chemistry. Thank you so much, Irina. Distinguished colleagues. Anyone else wanted to add up? Who wanted to add up? Well, first of all, Irina, you see, Igor and I quite recently chosen the new staff reserve assistants for our department and senior lecturers, and Irina had said that many young researchers submit 3 or 4 times submit their candidacies. Liliya, please submit your candidacy next year as well. But we see that Lily is a fighter, and we all know that Lily is sick today. And yes, no need to say that. But everything will change next year. And still, I want to say that I liked the work because it's very targeted. And when I talk about physical and chemical component, quite frequently researchers give the data on, for example, Gibbs energy, and it's unclear why they give it. And at one international conference, I said that that's a kind of thermodynamic, accessory, and that's something that Liliya does not have. And Anatoly Rusonov, the student of Irina Alexeyevna, he said that physics and chemistry work should have formulas. And after the end of this defense, I said that I have you. I'm referring to academician Rusonov, and by the way, the graduate of our department. And I said that I have your monography, and I found no formulas there. And he said that he lost it, and he can't consult it. And, physical-chemical work should have more physical-chemical formulas. But still, I like this work a lot, because that's a targeted work without any accessories, without any scientific hypocrisy, when you have a lot of thermodynamic data which is quite unnecessary, which is not used. So this work is quite a good one. Well, as they say, initially there was a word, therefore the idea is of particular importance. Irene. Yes. Anyone else to add up? Well, Liliya, as for the specific catalytic activity, certainly there is this definition. This is the speed of catalytic reaction minus the speed of non-catalytic reaction multiplied by the share of surface and divided by superficial concentration of the catalyst. That's an exact definition, and you have a different one. I believe you really changed the places of selectiveness and a specific catalytic activity. The more so, you should have compared them with non-catalytic process. You shouldn't have taken catalysts, but you should have taken catalysts, and indeed this conversion goes without the catalyst. Certainly the yield is lower, but it will be the classical heterogeneous catalytic activity. And quite recently we had a defense at Technological University, and Fischer-Tropsch reaction is not catalytic at all. And they are shifting to very high temperatures in order to secure yield, but there is this reaction there. Yes? That was not me. Okay. Yes, Nikolai is the graduate of our department, therefore he pays attention to the quantitative interpretation of data. Yes, certainly I agree with that. But basically I like the work a lot. Certainly I agree with it. Yes, thank you. Yes, it turns out independently. So I need to ask the members of the board, before we draw conclusions and before the vote, I need to ask if there are any questions or comments on the procedure of our defense shortly. I believe that I heard everything quite well. I've seen everything quite well. No questions about that. Okay, thank you. Now let's shift to the next article on our agenda, the vote. And now it's 2 minutes past 4. And dear colleagues, we have an opportunity to declare a break to discuss the defense with sound sound turned off. No, we don't need this break. No need for that. Yes? Colleagues, no need for that. No, we believe there's no need for that. Okay. And as a chairman, I also support it. Yes, the microphones are working in a couple. Okay, let's continue and let's shift to the vote. And I solicit the opinions of the members of our board. So please. Who was the first to read the review? Raisa. Yes, I turn on the microphone. Yes, I certainly vote for. Okay. Andrei, what about you? Yes, certainly I vote for the award of the degree. Yes, dear colleagues. Yes, I vote for. Alexander, what about you? Yes, I also vote for the award of the academic degree, and I also support the award of the academic degree because I really like the work a lot. Well then, dear colleagues, out of the 5 voting members, 5 voted for the award of the academic degree, and no one abstained from the vote, and no one voted against the award of the academic degree. Therefore, we award the academic degree of the candidate of sciences and chemistry to Ms. Liliya Yafarova in specialization physical chemistry. So that's the decision that we made. Dear colleagues, as our session is held partially online, I would like to ask the members of the board or the candidate for the degree have any comments on the procedure of the defense. No comments on that. No comments. Okay. Now I would like to give the floor to Liliya for conclusion. So please, Liliya, have the floor. Thank you very much, Igor Vasilyevich and the members of the board. First of all, I would like to thank you for the interesting discussion, for the interesting question and valuable comments for your work. And defense, I would like to thank the doctor of chemical sciences, Professor Lisitsyn, and I would also like to thank Professor Cherepanov for the interest in my work and for their remarks. And certainly I would like to thank my academic supervisor, Professor Irina Zvereva, and head of the Department of Thermodynamics, Professor Toiker. And I would like to thank my colleagues, Irina, Alexey Likov, Mr. Rodionov, and I would like to thank all the students and PhD students of Physical Thermodynamics and Kinetics, Department of St. Petersburg State University, and I would like to thank the Resource Center of Tomogravimetric and Colorimetric Methods of Study. And I would like to thank the Department of Physical and Colloid Chemistry Department of the People's Friendship University of Russia, Professor Mamontov, and the Lab of Catalytic Test Research of Tomsk State University. And I would also like to thank the Institute of Catalysis of Leibniz for the opportunity to work in an academic group for cooperation. And I would like to thank them for cooperation. And I would like to thank the Dissertation Support Defense expert Natalia Karpova for her help in the organization of this remote format of defense. And certainly I would like to thank my family, my parents, the parents of my husband, for full support, for their belief, for love. And I would like to thank everyone. And I would like to thank my husband, who is a real motivator for me. He supported me in difficult situations. Once again, thank you all. Thank you. Yes, really, that's an exemplary remark. For 35 years, I've been heading the academic councils, and for the first time, I hear such a gratitude. Yes, Liliya should submit it in the written form. Yes, Liliya, I believe on behalf of all the members of the board, I would like to congratulate you with the successful defense. Indeed, you've shown a very good class of work, and there was a very good presentation, and you answered the questions quite well, and you really felt this atmosphere of classical university when the members of the board really gave a kind of master class discussing the issues that you should have described in more detail. And in order to see, sometimes you need to change your point of view. So in this regard, I believe it's wonderful that we had this public discussion, and I believe you had a very good presentation. So we congratulate Liliya. Dear colleagues, I would like to thank all the members of the board. You worked quite wonderfully, and I would like to thank our colleagues in Minsk and in Saratov for remote connection. Thank you so much for joining us at this session. Thank you very much for taking your time to get acquainted with the thesis. Yes, so now we are acquainted, now we'll keep in touch, and you can always contact us if you need our help. So that's basically it, dear colleagues. We're finished up here. Yes, just a remark, quick remark. Distinguished colleagues, let me congratulate Liliya and also the academic supervisor and also head of the department, Alexander Matveyevich, with this successful defense. I understand that that's the achievement of all the scientists who supported our candidate for the degree, and I wish you successful defenses in the future. Yes, thank you so much indeed. You're right, and I forgot to congratulate Irina with it. Yes, Irina, we congratulate you as well. Yes, thank you, dear colleagues. I believe here we'll stop and